13.8 billion years ago, everything you know, every planet, every star, every atom in your body, almost didn't exist. Because in the very first moments of the universe, matter and antimatter should have destroyed each other completely. Yet somehow matter survived, and you're here to hear this story. Physics tells us when the universe began, it produced equal number of matter and antimatter, perfect cosmic twins. Same mass, opposite charge. But when they meet, they annihilate in a burst of pure energy. If nature had played fair, all we'd have left today would be light. No planets, no galaxies, no life. And yet, here we are. Every atom in the universe, from the sun to the cells in your body, is made from matter. Not a single piece of antimatter remains, at least not in our part of the cosmos. The question is, why? What tilted the cosmic scales in favor of matter? To find the answer, we need to rewind to the first trillionth of a second after the Big Bang. The newborn universe was chaos, temperatures of 100 million trillion degrees, particles slamming into each other at unimaginable speeds. Matter and antimatter were born together, danced briefly, and then destroy each other in flashes of gamma rays. But something strange happened. For every billion pairs that annihilated, only one lonely particle of matter escaped destruction. 1 in a billion, so rare it's almost like winning the cosmic lottery. And those rare survivors became the seeds of everything we see today. Think about it. For every billion photons of light in the universe today, there's just one lonely proton, the leftover matter from that imbalance. If that tiny fraction hadn't survived, the universe would be nothing but a cold, empty ocean of radiation. So where did this imbalance come from? Physicists believe the answer might lie in a rule-breaking phenomenon called CP violation. In this theory, the laws of physics should treat matter and antimatter the same. Charge, C, and parity, P, should be preserved. But experiments have shown that certain subatomic particles, like kaons and B mesons, decay slightly differently than their antimatter counterparts. It's a tiny effect, but on the scale of the universe, even the smallest bias can decide whether we exist or vanish. Some scientists think CP violation isn't enough to explain the imbalance. This leads to more exotic ideas, like baryogenesis, a set of processes in the early universe that might have created extra matter. These could involve particles we've never detected, forces we don't yet understand, or even physics that breaks the standard model entirely. And here's where it gets truly mind-bending. If matter dominated here, could antimatter have won somewhere else? Imagine a distant galaxy made entirely of antimatter, anti-stars burning, anti-light, anti-planets orbiting in alien skies. We haven't found any, but if we did, contact between our matter and theirs would be catastrophic, a release of energy beyond anything we could imagine. Every galaxy, every planet, every life form owes its existence to that 1 in a billion imbalance. You are literally built from the survivors of the universe's first great war, the war between matter and antimatter. We still don't know exactly why matter won, but we're getting closer, and the answer could change everything we know about physics. And maybe, just maybe, reveal that we are not alone in our type of universe. In the next video, we'll explore what would happen if you fell into a black hole and saw the end of time itself.